so we can understand the best way to manufacture this vehicle when we go down to the Michoud assembly facility.
So at this point, are we ready to take it from the computer and actually start building this hardware?
Yes, we are, and as a matter of fact, we're putting a system together to do friction stir welding that's going to build hardware that we're testing here at Marshall Space Flight Center.
Can we go check that out?
Sure.
I'm here with Bob Carter, and he's the welding engineer for the new robotic weld tool here in Building 4755. And Bob, that is a really big machine right there. Tell me what it does.
Okay, well, the robotic weld tool is a new friction stir welding system that we are building here at the Marshall Space Flight Center. The robotic weld tool will be a seven-axis, 7 degree of freedom robot that will be used to weld the bulkheads and dome sections for the Ares 1 upper stage.
And what makes it unique to Marshall?
What makes this system unique is the fact that it's a 7 degree of freedom robot. This will be the first friction stir welding system here at Marshall that will be capable of making what we call complex curvature welds. That's a weld that has more than one curve in it, or it's not just a straight linear weld. So for the Ares 1 upper stage, we'll be using this machine to make what we call gore welds, which join panels that form the dome section for the forward hydrogen tank.
And I understand it's the largest friction stir weld, or one of the largest in the world. What is friction stir welding?
Okay, yes, this system will be one of the largest friction stir welding systems in the world. I hesitate to say that it is the largest because there's always a bigger one out there. But friction stir welding is a solid state welding process. Solid state means that there is no melting involved in friction stir welding. And the fact that there is no melting means that friction stir welding has a couple advantages over conventional fusion welding. One of those is that there's a reduced propensity to form defects such as porosity, hot cracking, those sorts of things that are real common in fusion welding. Also, because there's no melting, it has what we call a higher joint efficiency or a higher weld strength. So the fact that we've got a higher strength and fewer defects means that it's a more robust process, more robust welding process. And ultimately, when we implement this on the vehicle, it makes the vehicle more robust, more reliable. And also, since we've got higher weld strengths, we can reduce the weld land thicknesses, which even can make the vehicle a little bit lighter.
And it's not going to be alone in this building, right?
No, the robotic weld tool, we're actually going to have 3 major weld tools in this building. There will be the robotic weld tool, there will be a vertical weld tool, and a circumferential weld tool. The vertical weld tool is used to build the barrel sections for the Ares 1 upper stage, and then the circumferential weld tool will be used to make what we call major welds, or the circumferential welds that join the barrels to barrels or the barrels to bulkheads, and ultimately that's where the vehicle starts to look like a vehicle in our circumferential weld tool.
Can't wait to see it, and I know you're going to invite us back when all that work's going on.
I will. Thank you.
Thanks. I'm here with Danny Davis, and he is the upper stage element manager for Ares 1. And Danny, tell me how you'll be using friction stir welding for the upper stage.
The friction stir weld process is a critical part of our manufacturing plan. With the friction stir developments, we're able to build lightweight, very strong, and low-cost structure for the upper stage element.
And tell me how all this fits in with NASA's mission with the Ares 1.
Well, the Ares 1 consists of a booster stage and an upper stage. We have a boost burn and then a second stage burn. The upper stage provides that second stage of propulsion, which will be used to deliver the Orion spacecraft into the low Earth orbit.
And I know you work very closely with folks in the engineering directorate here in Marshall. Tell me about that relationship.
We're very excited about the opportunity we have. The administration has asked us to do an in-house design and development of the upper stage. This means that our NASA workforce, our NASA engineering team, and the bulk of it here at Marshall, will be designing, developing, testing, and eventually providing all the specifications and drawing to a production contractor for fabrication of the upper stage.
And that's not just for Ares 1, too. You'll also be working on the Ares 5, right?
The work we do today on the Ares 1 upper stage is very important and sets the stage for the work on the Ares 5 upper stage and core stage. The friction stir techniques that we develop, the welding techniques, the testing techniques, all of these are very applicable to the future development of the Ares 5 vehicle.
All right, a lot of exciting work ahead. Thanks, Danny.
You're welcome. Thank you.
Thanks a lot for watching.
Find out where we turn up next as we focus on Marshall.